why does time only move forward? Why can't we rewind events, like unbreaking a glass or watching the universe shrink back to its beginning? The answer lies in one of the most fundamental concepts in physics, entropy. Entropy explains the arrow of time, the reason why time flows in one direction and not the other. Welcome to Grossdenken, my friends. In this video, we'll dive into the fascinating connection between entropy, the laws of thermodynamics, and the nature of time itself. Let's unravel one of the greatest mysteries of the universe. But before that, let me ask you to support this channel by just subscribing. That would mean a great help. First, what exactly is entropy? Entropy is a concept in thermodynamics, the study of heat, energy, and work. It measures the amount of disorder or randomness in a system. The higher the entropy, the more disordered the system is. For example, imagine a block of ice. Its molecules are neatly arranged in a solid structure, so it has low entropy. When the ice melts into water, the molecules move freely and randomly, increasing entropy. In simple terms, entropy describes how organized or disorganized something is. And here's the key. The second law of thermodynamics states that entropy in a closed system will always either increase or stay the same over time. This is why things naturally go from order to disorder. But what does entropy have to do with time? The arrow of time refers to the fact that time moves in one direction, forward. We never see a shattered glass spontaneously reassemble or smoke return to a fire. These processes happen in one direction because they all follow the increase of entropy. Entropy gives time its direction. When things move from order to disorder, like ice melting or the universe expanding, those processes are irreversible. And because entropy naturally increases, we perceive time as always moving forward. In scientific terms, the arrow of time points in the direction of increasing entropy. To understand the bigger picture, let's look at the universe itself. At the moment of the Big Bang, about 13.8 billion years ago, the universe was in a state of very low entropy, highly ordered and compact. Over time, the universe expanded and became more disordered, with stars, galaxies, and other structures forming. Today, the universe continues to expand, spreading energy and matter across a vast, chaotic space. This means the entropy of the universe is constantly increasing. Eventually, scientists predict the universe will reach a state of maximum entropy, sometimes called the heat death of the universe. In this state, everything will be so evenly distributed that no work, energy transfer, or complexity will be possible. Time, as we understand it, might lose its meaning. So, why can't time reverse? In theory, the laws of physics don't actually forbid time from moving backward. For example, the equations of motion in both classical mechanics and quantum mechanics are time-symmetric, which means they work the same whether time moves forward or backward. However, in reality, we just don't observe time moving backward because of entropy. High entropy states are far more likely than low entropy states. For instance, a messy room is more probable than a perfectly clean one. If you drop cream into coffee, it mixes and increases entropy. The odds of the cream unmixing and returning to its original state are so astronomically low that it's practically impossible. This natural tendency for entropy to increase is what makes time asymmetrical in our everyday experience. Does the arrow of time have a starting point? According to our current scientific understanding, yes, it began at the Big Bang, when the universe was in its most ordered state, with very low entropy. As the universe evolves, entropy increases and time continues moving forward. But what about the end? If the universe reaches maximum entropy, time may actually lose its meaning. Without differences in energy or order, there would be no way to distinguish one moment from the next. This scenario is speculative, but it's a possibility that physicists have considered when thinking about the far future of the cosmos. Interestingly, life itself exists because of entropy. While living organisms might seem highly ordered, they actually increase entropy in their surroundings. For example, when we eat food, we extract energy to build and maintain complex systems in our bodies. But in doing so, we produce waste and heat, which increases entropy overall. This is true for all life forms. They create local order but contribute to the universal increase in entropy. In this way, life is both a product of and a participant in the arrow of time. Entropy and the arrow of time reveal a deep connection between the physical laws of the universe and our perception of reality. Time moves forward because entropy increases, creating a one-way street that defines everything from the motion of galaxies to the melting of ice. But honestly, there's still so much we don't understand about time. Could the arrow of time ever reverse? Is there a deeper reason why entropy increases? These are questions scientists are still exploring. Thank you for joining us on this journey through entropy and the arrow of time. Don't forget to like, subscribe, and share your thoughts in the comments. What do you think about the nature of time?